Hi, this is TW Huang. Today, I'm going to talk about exception handling in Taskflow. This is an introduction of how Taskflow captures and propagates errors in task parallel programs. In this presentation, we will first understand the core exception handling logic in Taskflow and look at the algorithm flow behind it. Next, we will walk through a few practical examples to help you understand how Taskflow handles exceptions. Finally, we will conclude the talk. Exception handling is a key feature that sets Taskflow apart from existing libraries that cannot handle exceptions. For example, if you ever use OpenMP, it has no standard mechanism to propagate exceptions across threads. Throwing an exception within the OpenMP parallel region is an undefined behavior. In fact, based on our user experience, exception handling is a major reason why Taskflow is adopted by many real-world production systems. It was first requested by an industrial user in a semiconductor company and later iterated, refined, and enhanced over time by other use cases. You probably already know, exception handling is very challenging in a multi-threaded environment because multiple tasks can throw exceptions simultaneously in unpredictable ways. To overcome this challenge, Taskflow has a simple but robust design to handle exceptions in a task parallel environment based on the following three scenarios. Number 1, synchronous exception propagation, which immediately propagates the exception to the waiting thread. Number 2, asynchronous exception propagation, which propagates the exception to the shared state. Number 3, silent exception propagation, which silently stores the exception within the task. When multiple scenarios occur, Taskflow resolves them by applying scenario number 1 first, then scenario number 2, and finally scenario number 3. Let's take a look at the first scenario, synchronous exception propagation. Under this scenario, exceptions are propagated immediately to the caller thread that is waiting for the execution to complete, such as a code-run loop of cooperative execution. For example, the code below issues a code run on the task flow from a worker thread W1 in an executor. The task flow has only one task that throws an exception. When a worker runs the task and throws that exception, it will be propagated to worker W1 and handled by its try-catch block. Now, let's move on to the scenario number 2, asynchronous exception handling, where the exception is captured and propagated to the shared state. And this exception will later be rethrown when you access the result of the shared state, such as calling the get function from the return future object. For example, the code below submits a task flow to the executor and gets a return of TF future. When the task flow throws an exception, that exception will be propagated to the shared state and can be caught by the get function. The final scenario represents a fallback when scenarios number 1 and number 2 do not apply. In this case, the exception will be silently captured and stored within each task. For example, as you can see from the code below, the exception that occurs in the first silent async task will be silently captured within the task because there is no parent context to handle this exception. For the second example, we create a task group inside a silent async task and use it to launch another silent async task that throws an exception. In this case, the silent async task is parented to that task group, and therefore its exception can be explicitly caught when we issue a cooperative execution from that task group. You can retrieve the exception pointer from a task, which is useful for you to examine all the possible errors in your task flow. Since we are in a multi-threaded environment and exception handling is relatively sequential, when multiple tasks throw exceptions simultaneously, only one will be propagated. Other unpropagated exceptions will be silently stored within their respective tasks and can be later retrieved using the exception PTR method in TF task. For example, the code below creates a task flow with 2 tasks, both of which throw exceptions. However, given the sequential nature of try-catch block, only one exception can be caught, while the other will be silently stored inside its task. That's why we place an exclusive assertion at the end of this code. Now, let's examine the algorithm flow of exception handling. This figure shows how Taskflow decides where to handle an exception based on available execution context. When a task throws, the executor walks up the task hierarchy, marks the path as exceptional, and looks for an anchor node that can catch it. If it finds an explicit anchor, like a blocking colon or join, the exception is immediately rethrown to the waiting thread. Otherwise, it checks for a shared state to report the exception asynchronously, or propagates it to the nearest implicit anchor, such as a parent task group and a parent runtime task. Only if none of these exist does the runtime store the exception locally in the task. In this case, exceptions are silently called by the executor. In fact, you can think of the algorithm in a simple way. When a task throws an exception, ask the following 3 questions in order. First, is there any parent context waiting for the execution to complete? If yes, you write a try-catch block in that parent context to handle the exception. Otherwise, you ask the second question, is there any parent context associated with the shared state to which the exception can go? If yes, you write a try-catch block to access the result from that shared state. Otherwise, you go to the next question, where the exception will be silently stored in the task. It's important to notice that exception handling in Taskflow has a non-deterministic behavior. Taskflow can only propagate one exception, although many tasks can throw simultaneously. Which exception is propagated is completely dynamic and depending on the runtime. So, you should never count on exception handling to perform control flow logic. Now, let's walk through some practical examples so you can understand the exception handling logic of Taskflow better. The first example is catching an exception from a colon loop. Here, I have 2 task flows, Taskflow 1 and Taskflow 2. Taskflow 1 has a task that will throw an exception, while Taskflow 2 has a task that will co-run Taskflow 1 using cooperative execution. When we run Taskflow 2, we will get a future. But since there is a co-run representing scenario number 1, the exception thrown by Taskflow 1 will be caught by the co-run loop and won't be propagated to the shared state associated with that future object of running Taskflow 2. In this example, we issue a co-run from a runtime task instead of the executor. There is no difference in terms of exception handling logic, and we can observe the same behavior as the previous slide. The second example is catching an exception from a running task flow. Here, I have a task flow with one task that will throw. When we run this task flow, we can get a future object. Now, when a task throws, the executor captures it and propagates it to the shared state associated with the future object, from which you can catch the exception by calling the get method. It's important to notice that when a task throws an exception, the executor will cancel the execution of its parent task flow. That is, all the subsequent tasks that depend on the exception-throwing task will not be executed. For example, here I have a task flow of 2 tasks, A and B, where A runs before B. When task A throws an exception, its parent task flow will be cancelled by the executor, and task B will not be executed. As a result, in this case, the variable test will remain 0. The next example is catching an exception from a silent async task. Since silent async does not return any future object, any exception thrown by a silent async task will be either propagated to its parent context if one exists, or stored silently within its task if that parent context does not exist. For example, the first silent async task does not have any parent context, so its exception will be silently ignored as there is no way to catch it. The second silent async task is created by a runtime task, which acts as its parent. Since the runtime task does not use a try-catch to capture the exception will propagate up to the next parent context, the task flow itself. As a result, it ends up in the shared state of the running task flow. In today's presentation, we have understood the core exception handling logic of Taskflow and examined the algorithm flow behind this logic. Finally, we walked through several examples to see how Taskflow handles exception in practice. If you are interested in learning more about Taskflow, please check out our project website at taskflow.github.io. You can post your questions on the issue page of our GitHub repository. With that, I'm going to stop here. Thank you very much.